What's up guys, this is Youngno. Let's solve this question. In this question, we have an equation of a circle. Since we don't have any unknown constant here, we can just draw the graph of it. Here comes the Desmos. I'm just gonna draw 9 times x squared plus y squared equals 30x minus 12y minus 28. We have a very small circle. Let me zoom in. If you click somewhere on top and bottom, you can find the values of the coordinates of those 2 points. But we have a problem here. X coordinate of this point on top is not equal to 1.667. It's actually 1.66666 and so on. It has infinitely many sixes in there. The reason why we're getting this number from Desmos is Desmos is only able to show us a decimal number up to 3 decimal point. So when you have these kind of numbers like 333, 667, you cannot rely on those coordinate values. That means we're not allowed to find the value of diameter as the difference between these two, because that is not the exact value of those coordinates. So whenever you have those numbers from Desmos, graphical way would not work. So let's get rid of Desmos. And we have to do this in an algebraic way. Okay, let's do that. Let's simplify the given equation. Let's distribute that 9x squared and 9y squared. I'm just going to move these two terms to the left side. And we have negative 30x here and plus 12y here. I'm just going to leave that negative 28 on the right side. To find the center of this circle and its radius, we're supposed to convert this equation into the standard form of circular equation. Here comes the standard form of circular equation. Its center is at h, k, and the value r is representing the radius. We're supposed to construct 2 perfect squares for x and y. That means we have to complete the square 2 times, 1 for x and 1 for y. Let's do that. To complete the square, you have to make the quadratic coefficient into 1. So why don't we just divide everything by 9? Then we have x squared minus 30 over 9x and y squared and 12 over 9y and negative 28 over 9. Let me make some room here because we have to add some constants. 30 over 9 is 10 over 3, so I'm just going to replace it with 10 over 3. 12 over 9 is 4 over 3, so I'm just going to replace it with 4 over 3. Once you have the quadratic coefficient as 1, now we're ready to complete the square. You're supposed to take the linear coefficient and multiply 1/2 to it. Then we're getting negative 5 over 3, and you're supposed to square it. Then we have 25 over 9. That is the number you're supposed to add here. But once you add this number, your left-hand side value got changed. So let's add the same number onto the opposite side, then everything stays the same. Let's do the same thing for y terms. Since we already have 1 as the quadratic coefficient, we're ready. Take the linear coefficient, multiply 1/2, then we're getting 2/3, and square it, then we're getting 4 over 9. That's the number we need here, and let's add the same number both sides. Okay, we're ready. These 3 terms will make a perfect square. Since we have x squared here, we need x. We have 25 over 3, that is 5 over 3 squared. And since we have negative sign here, is put negative here. This is how to complete the square. If you're not familiar with these masses, you have to learn about this. Okay, here comes the y terms. These 3 terms will make a perfect square. Parenthesis, squared, y squared, we're supposed to have y here, 4 over 9, we're supposed to have 2 over 3. Plus sign, plus. Let's simplify this number, 1 over 9. The center is located at 5 over 3, comma, negative 2/3, and since 1 over 9 is equal to 1/3 squared, r squared, its radius is 1/3. We're almost done. Center at a, b. This is A and this is B, and the radius is C. So this is C. So the value of A minus B plus C is A minus B plus C. So common denominator, we have 5 and plus 2 and plus 1. So the final answer has to be 8 over 3. We're done. See you on the next question.